Dear students, welcome. This is our third class on simple harmonic motion. Today, I am going to solve some problems on simple harmonic motion. I have already written two questions. See question number 1. Today's question number 1, as I will do question number 6 because we have already done 5 questions. A body moving in a straight line, OAB, with simple harmonic motion has zero velocity when at points A and B, whose distances from O are A and B respectively, and a velocity V when halfway between them. So that the complete period is this. We have to find the time period of simple harmonic motion. A body moving in a straight line OAB. Suppose this is O, A and B. OAB has zero velocity when at points A and B. When the particle velocity, here the velocity of the particle is equal to 0, and at the point A the velocity of the particle is also 0. Whose distances from O are A and B respectively. This is distance A from O to A, and from O to B, this distance is B. And a velocity V when halfway between them. Suppose C is the middle point of AB. The body is moving in a straight line OAB with simple harmonic motion. A and B, at the point A and B, the velocity of the particle is zero. This means that A and B are two positions of rest. Clearly, the middle point of AB should be the center of force of the simple harmonic motion. Center of simple harmonic motion. This is center of simple harmonic motion. Middle point, center of force. This is the center of force. You may write, let C be the middle point of AB. Let C be the middle point of AB. Let C be the middle point of AB. Therefore, C is the center of force, since the velocity of the particle at A and B are 0. At A and B are 0. Velocities, you may write the velocities are 0. Therefore, C is the middle point. Therefore, obviously, C is the center of force. Therefore, C is the center of force. Therefore, C is the center of force. C is the center of force. C is the middle point, C is the center of force. Next, OA is given to be small a, OB is given to be small b. Given that OA equal to small a and OB equal to small b. It is given. Let lambda be the amplitude of motion. Let lambda be the amplitude of motion. Let lambda be the amplitude of motion. Therefore, CB, of course, this is equal to CA equal to lambda. CB equal to lambda. This is CB, it is equal to lambda. Lambda equal to CB. This is equal to half of AB. Obviously, it is half of AB. C is the middle point of AB. Half of AB. This is equal to half. AB means OB minus OA. OB minus OA. This is equal to half. OB means B minus A. Half of B minus A. Therefore, amplitude of motion is half of B minus A. B minus A. Amplitude of motion is B minus A. Motion is half of B minus A. Amplitude is half of B minus A. Lambda is equal to half of B minus A. Now, P is the velocity when halfway between them. Means P is the velocity of the particle at C. P is the velocity of the particle at C. Given that P is the velocity of the particle at C. Given that P is the velocity of the particle at C. P is the velocity of the particle at C. P is the velocity of the particle at C. In simple harmonic motion we have to find the time period, means twice pi by root mu. Twice pi by root mu means we have to find the root mu. In simple harmonic motion we have P square equal to mu into A square minus X square. Here, what is A? A means amplitude. Here, amplitude is equal to lambda. Lambda square minus X square. Where V is the velocity of the particle when it is at a distance x from the center of force O, from the center of force C, and lambda is the amplitude. Here, lambda is amplitude. Lambda is equal to amplitude. Lambda is equal to amplitude. V is the velocity of the particle when it is at a distance x from the center of force. This means where V is the lambda is equal to amplitude, V is the velocity of the particle. When it is at a distance, x, from the center of force C. When it is at a distance x from the center of force C. Given that V is the velocity at the point C. Given that V is the velocity of the particle at the point C. Given that velocity is equal to V. V is the velocity of the particle at C, at the point C. When x is equal to 0, you may write here at the point C. V is the velocity of the particle at the point C. Amplitude is half of B minus A. At the point C, velocity is V, and the distance of the particle from the center of force is 0 here. Here it is velocity equal to V. Half of B minus A. Amplitude is half of B minus A. Therefore, from 1 you will get V square equal to mu into lambda square minus 0 square. This means V square equal to mu into lambda square. This means that V square equal to mu, lambda means B minus A divided by 2 whole square. Since the amplitude of motion is B minus A divided by 2. This means that mu equal to twice V by B minus A whole square. Mu equal to twice V divided by B minus A whole square. Root mu equal to twice V by B minus A. Equal to twice V divided by B minus A. Root mu equal to twice V divided by B minus A. Therefore, you have to find the complete period. Therefore, the time period, periodic time. Therefore, the time period is twice pi by root mu. Therefore, the time period is period is equal to twice pi by root mu. This is equal to twice pi by root mu means you may write twice v by v minus a. Twice v by v minus a. Therefore, time period equal to twice pi into b minus a divided by twice pi into b minus a divided by 2 times of b. 2 will be cancelled. Therefore, the time period is equal to pi into b minus a divided by v. Pi into b minus a divided by v. This is the time period. We have proved that the periodic time or time period is pi into b minus a divided by v. Therefore, we have solved question number 6. Perhaps you have understood this one. What is this? You have to find the time period. You should know the formula for time period. Time period is twice pi by root mu. You have to find the value of mu or root mu. Given that velocity at the middle point means you have been given the velocity at the center of force, means when x is equal to 0, velocity is given. And you have to find the time period in terms of v. Also a and b are given. You should find the amplitude of motion. Therefore, the amplitude of motion, also just put the amplitude of motion in the formula. V square equal to mu into a square minus x square. Here we have written lambda in place of a, means in place of amplitude, because a has already been given in the question. That's all. Perhaps you have understood question number 6. Now come to solve the question number 7. We have solved this one. Question. Let me remove this one. 6. Now come to question number 7. What is? In the question number 7, it is given that a particle executes simple harmonic motion of amplitude a in a straight line. If t be the time period and v be the velocity of the particle at distance x from the center, so that integration 0 to capital T v square dt equal to twice pi square a square. Here a is the amplitude. Here it is given that in simple harmonic motion, given that a is amplitude, t is time period, v is the velocity of the particle at distance x. Distance x. In simple harmonic motion, given that solution, given that amplitude equal to given that amplitude in simple harmonic motion, in the question in simple harmonic motion, amplitude equal to a, time period equal to capital T equal to capital T. It is given, and v is the velocity of the particle when it is at a distance x from the center, and v is the velocity of the particle. Velocity of the particle, and v is the velocity of the particle at a distance x from the center. At a distance x from the center. From the center. In simple harmonic motion we have. V square equal to mu. A is given to be amplitude and v is the velocity of the particle when it is at a distance x from the center of force. Therefore, in simple harmonic motion we have v square is equal to mu into a square minus x square. And x equal to a cos root mu t. Mu is the intensity of force, x is the distance of the particle at time t. You may write where symbols have their usual meanings. In simple harmonic motion, x is the distance of the particle when it is at the particle at time t. Mu is the intensity of force. Where symbols have their usual meanings. Have their usual meanings. where symbols have their usual meaning. Now v square equal to mu into a square minus x square. This is equal to mu a square minus x means a cos root mu t. A square cos square root mu t. You may write like this. Since x is equal to a cos root mu t. In simple harmonic motion we have this. Or you may write mu a square 1 minus cos square root mu t. Or you may write mu a square sin square root mu t. You may write like this. A square sin square root mu t. You have to find 0 to capital T. T is the periodic time or time period of simple harmonic motion. Now let me write in this side. Therefore, integration 0 to capital T v square dt equal to integration 0 to t. V square means you may write mu a square sin square root mu t dt. V square is equal to this. You may write like this. Here it is 1, it is 2 by 2. You may write here by 2 and this is 3 by 3. You may write like this. Mu and A are constants. Intensity of force, A is the amplitude of motion. It is constant. 0 to capital T. Sin square root mu t dt. Sin square root mu t dt. Now, this is equal to mu a square 0 to t 1 minus cos twice root mu t divided by 2 dt. Since sin square theta equal to 1 minus cos 2 theta divided by 2. 1 minus cos 2 theta divided by 2. Sin square theta is equal to, in class 11 formula, sin square theta is equal to 1 minus cos 2 theta divided by 2. This is equal to mu a square divided by 2. 1, it is t, minus sin 2 root mu t divided by 2 times of root mu. 0 to capital T. It is 2 times of. Since integration cos 2t cos m theta, suppose cos mx dx equal to sin mx divided by m. Sin mx divided by m. Sin mx divided by m. It is 0 to t. Mu a square divided by 2. Put the limits. Minus sin twice root mu capital T divided by twice root mu minus 0 minus sin 0 divided by twice root mu. You may write like this. This is equal to mu a square divided by 2 t minus sin twice root mu t divided by twice root mu. Twice root mu. In simple harmonic motion, t is the time period. Now, t is the time period or periodic time. T is equal to twice pi by root mu. Now, t is equal to twice pi by root mu. Suppose this is number 4. Now, t is equal to twice pi by root mu. T equal to twice pi divided by root mu. T is equal to twice pi by root mu. This means root mu equal to twice pi by t. Means mu equal to 4 pi square divided by t square. 4 pi square divided by t square. 4 implies. Therefore, 4 implies. From 4 you will get 0 to t v square dt equal to mu square divided by 2 t minus sine twice root mu twice pi by root mu divided by twice root mu. You may write like this. Now, this is equal to mu square divided by t. 2, this mu cancel, you will get sine 4 pi divided by twice root mu. Sine 4 pi means 0. This is equal to mu. Mu means 4 pi square by t square. 4 pi square by t square. A square divided by 2 into t minus 0. Since sine 4 pi equal to 0. Since sine 4 pi equal to 0, number 1. And mu equal to 4 pi square by a square, t square. Mu equal to 4 pi square by t square. This is equal to this is equal to 4 pi square by t square a square 4 pi square 2 into t square a square into capital T. This 2 you will get this 1t will be cancelled. This is equal to twice pi square a square divided by t. Therefore, twice pi square a square divided by t. Therefore, it is therefore integration 0 to t p square dt equal to twice pi square a square divided by t. Twice pi square a square divided by t. Therefore, we have solved these two problems. Let us take one more problem. Let us take one more. Let us try to solve this problem. What is it? Show that if the displacement of a particle in a straight line is expressed by the equation x equal to a cos nt plus b sin nt, if this describes a simple harmonic motion whose amplitude is this root over a square plus b square and period is twice pi by m, we have to show that the motion is simple harmonic with time period twice pi by m and amplitude of the motion is root over a square plus b square. Root over a square plus b square. Given that x equal to, given that x equal to a cos nt plus b sin nt, this means dx by dt, differentiate with respect to t, differentiate with respect to t, you will get minus am sin nt plus bm cos nt, you will get this one. Also d2x by dt square, again differentiate it, minus am square cos nt plus, not plus, it is minus, it will be minus, minus bn square sin nt. This means d2x by dt square equal to minus n square a cos nt plus b sin nt. A cos nt plus b sin nt. Suppose this is number 1. Suppose this is number 2. And d2x by dt square equal to minus n square x. Minus n square x. Just let me remind you the definition of simple harmonic motion. A particle is said to execute simple harmonic motion if it moves in a straight line such that its acceleration is always directed towards a fixed point in the line. The negative sign shows that the particle is attracted towards the fixed point and is proportional to the distance of the particle minus a constant into x, which represents a simple harmonic motion. Which represents a simple harmonic. This shows that it represents a simple harmonic motion. Represents a simple harmonic motion with center center at x is equal to 0 and time period equal to twice pi by root mu means root over n square, twice pi by n. Time period is twice pi by n. We have proved this. The time period is twice pi by n. Periodic time or time period is twice pi by n. Now you see here. Describe a simple harmonic motion with amplitude. We have proved that the motion is simple harmonic because the acceleration equal to minus a constant x. It is simple harmonic motion. The periodic time twice pi by n. We have proved this one also. Now amplitude. What is amplitude? What is amplitude? Amplitude is nothing but a distance between the center of force and the position of rest. The distance between the center of force and position of rest. You see here, this is the center of force O. Here it is the velocity v equal to 0. Here it is the velocity equal to 0. The distance between the center of force and the position of rest. This distance is called if it is the center of force. Center of force, then this distance is the amplitude of motion. This is the amplitude of motion. Now, we always measure the x. Suppose p is the position of the particle, where its distance from the center of force is x. We always measure the distance from the center of force. Now, this distance is x. It will be the amplitude if the velocity of the particle at p is equal to 0. Means x is the amplitude where the velocity of the particle becomes 0. This means that the amplitude, we have to find the amplitude of motion. Amplitude is nothing but a distance where its velocity is 0. Here the velocity is 0. Its distance from the center of force, this distance is called the amplitude. Therefore we can say that x is the amplitude of motion. X is the amplitude of motion where the velocity of the particle is equal to 0. X is the amplitude. X is the amplitude of motion. X is the amplitude of motion. X is the amplitude of motion where the velocity of the particle is 0. Where the velocity of the particle is 0. Velocity of the particle is 0. Now, velocity means dx by dt. Now, putting dx by dt equal to 0 into, we get. Now, putting dx by dt equal to 0 into, we get. Putting dx by dt, the velocity equal to 0, into, we get. 0 equal to minus a n sin n t plus b n cos n t. This means n will be cancelled. A sin n t equal to b cos n t. B cos n t. B cos n t. This means sin n t divided by b equal to cos n t divided by a equal to root over sin square n t plus cos square n t divided by root over b square plus a square equal to 1 divided by root over a square plus b square. 1 divided by root over a square plus b square. Let me write here. You have to show that the amplitude of motion is root over a square plus b square. This means that from here you may write, this means that sin n t equal to b by root over a square plus b square. Cos n t equal to A divided by root over A square plus B square. A divided by root over A square plus B square. Therefore, amplitude of motion is just put you will find the values of sin and and cos and in another method also. Now, no, keep it within the bracket. Now, A sin and equal to B cos and A sin and equal to B cos and This means sin and divided by cos and equal to B by A. This means tan and equal to B by A. This means tan square and equal to B square by A square. You may write like this. B square by A square. This means that 1 plus tan square and equal to 1 plus B square divided by A square. This means 6 square and equal to A square plus B square divided by A square. You may write like this. This means cos square and equal to A square divided by A square plus B square. A square divided by A square plus B square. This means cos and equal to A divided by root over A square plus B square. A divided by root over A square plus B square. This one. Sin square and sin square and sin square is equal to 1 minus cos square and You may write like this. This is equal to 1 minus, what is cos square and A square divided by A square plus B square. A square plus B square. This is equal to A square plus B square. A square plus B square minus A square. This is equal to B square divided by A square plus B square. This means sin and equal to B divided by A square plus B square under this one. You may find the values of cos and sin and in this way also. Now you see that x is the amplitude of motion where the velocity of the particle becomes 0. But when the velocity of the particle becomes 0, then sin and equal to B divided by root over A square plus B square, and the cos and equal to A divided by root over A square plus B square. Therefore, x is the amplitude. Putting these values of sin and cos and in 1, we get the required amplitude of motion. Putting these values of sin and cos and now we have written note. You may find the values of sin and cos and in this way also. You may find the values of sin and cos and in the previous way also. Now, putting the values of cos and sin and in 1, we get the required amplitude. Putting these values of cos and sin and in 1, we get the required amplitude of motion. We get the amplitude of motion, which is amplitude. Therefore, amplitude equal to here A. What is cos and equal to A divided by root over A square plus B square plus B sin and means B divided by root over A square plus B square. This is equal A square divided by root over A square plus B square divided by root over A square plus B square. This is equal to A square plus B square divided by root over A square plus B square equal to under root A square plus B square. This is equal to A square plus B square. Therefore, amplitude of motion is root over A square plus B square. Therefore, amplitude is equal to root over A square plus B square. We have proved this one. Particle moves under the law x is equal to A cos root nt plus b sin nt. The motion is simple harmonic with time period twice pi by n. Also, The amplitude of motion is root over a square plus b square. Dear students, I want to stop here. Thanks for attending the class. Thank you very much. Thank you.